Hello students, let us continue with the problems in root locus. The seventh problem is to sketch the root locus for a unity feedback system whose open loop transfer function is g of s equal to k divided by s into s plus 4 into square plus 4s plus 20. Okay, now we know the open loop transfer function from this will be directly it is g of s into h of s, which will be equal to k divided by s into s plus 4 into s square plus 4s plus 20. Looking at the inspecting the transfer function, we see the number of zeros. Zeros, where do we get the zeros? We get the zeros from the numerator. Okay, the numerators will give the zeros. This is zeros is got from the numerator, poles are got from the denominator. Because we don't have any values here, we consider the number of zeros to be 0, and we have poles. We have a pole from this, we have a pole from this, and because it's a square, we will have 2 poles. So totally 4 poles, 1 at 0, minus 4. Then from the solution of this equation will give us 2 more poles. Total p value is 4. Okay, next we'll have to mark all this on the graph. Okay, next after this we have to mark the region of the pole root locus. If you look at this here, this region is the region of root locus, isn't it? Suppose how do we find whether it is a region of root locus? We have to consider a test point. Let us consider a test point here. To the right hand side of the test point, to the right hand side of the test point, to the right hand side of the right hand side of the test point, what is the total number of poles plus zeros? How many poles and zeros is this test point having? It has only 1. Is it an odd number? If it is an odd number, then this region will become the region of root locus. This region is the region of root locus. Now what about here, from here to here, next region? In this region, what about in this region? Is this a region of root locus? No. This is not a region of root locus, because suppose we consider a test point here. If I am considering a test point, to the right side of this, what is the total number of poles and zeros? I have 1 here, 1, 2, 3, 4. Isn't it an even number? We have even number. The poles and total number of poles plus the total number of it is 4, which is an even number. So it cannot be this, that is from minus 2 to this minus 4. This region of the y-axis or x-axis or this real axis cannot be a part of root locus. It cannot be. Your root locus will not it will not go here at all. In this from minus 2 to minus 4, you will not have any root locus. The system will not have any line. It will not have any locus. It will not go from this region to this region. There is no question of it having a root locus in this region. Okay, now what about the after minus 4? Will there be, if we consider a test point anywhere here, to the right side, what is a poles and zero count? 1, 2, 3, 4, 5. It's an odd number, so it is a region of root locus. From here to here, it will be a region of root locus. I mean continuously till infinity, it will be a region of root locus. So from 0 to minus 2 and from minus 4 to infinity is a region of root locus. That is, this x-axis or the real axis will be a part of root locus. Whereas from here, okay, it is from here also. So whereas from minus 2 to minus 4, it is not a part of the root locus. Next, we have to consider the number of asymptote. Okay, now do we have a 0 in the equation? No, there is no 0. Suppose there is a 0. Suppose we have this is the real axis and sorry, imaginary, and this is the real axis. As we were discussing, this represents a pole and this usually represents a 0. If we have a 0 and if we have a 0 and a pole, always the root locus will start from the root locus will always start. It will start from a 0 and it will end towards, it will start from a pole and end towards a 0. It will terminate at a 0. Okay, it will start all the root locus. Your system will start traversing, or it will the system will have different values. It will have the behavior will always start from a pole, and has the gain or the system parameter. The k here represents the gain of different system parameter. Variation of the system parameter on a whole is represented as k. So as k varies, temperature, pressure, or all these values vary, k will vary. So at k0, the system is starting. It will be there on this pole. And as you're increasing the value of k, it will go along this, and finally at k infinity, it will end up here. That is a maximum value. So your root locus, that is your system behavior, can be defined over this line for different values, for different parameters change. When temperature changes, one of your value can be here. You can have a behavior. You can have a value here. You can have a it will come here. It will come here. It will come here. So for different values of k, you know the root locus. So it will start from a pole and it will end at a 0. So now how many poles do we have? We have 4 poles. Do we have a 0? No. So there is no 0 for it to end directly. But it will end. Where will it end at a 0? At an infinite value. Somewhere, if I have a pole here, okay, I'll assume that there is a 0 somewhere at infinity. I'll assume a 0 somewhere at infinity. So this is very far. But from here to here, the system, the root locus will start, and it will start moving towards this 0. So now how will it move? Will it move like this? Will it move like this? Will it come down like this? So there is a line which is going to help it go. So that is called asymptotes. And because we need 4 asymptotes, based on the equation, we calculate the angle. Okay. Next, centroid. As I said, there should be a point from where these angles, they will start projecting out. They'll start moving out. So that again, from the equation, we calculate it to be -2. Okay. Then yes, mark the centroid. Then using the protractor, mark all the angles. This is 45. Okay. This angle will be 45. This would be 45. And this would be 135. Correspondingly, the other two, you will have to mark the angle for the other two as well. Okay. Then after that, next what? We have to find the breakaway point or break-in. Breakaway point, when you have a pole, 2 poles, okay, if you have 2 poles here, there are 2 root locus which will start from these two. One will start like this. There is other root locus which will start from here. Okay, both of them will meet at this point and they'll break. We know that root locus starts from here. That is when the minimum value of, that is for a minimum value of k. Minimum value of system parameter. K is again the system parameter. So minimum value of k, it will start. Okay. Then here also for minimum value of k, it will start here. From this end also, it will start. Then as the k value increases, this is k value should go on increasing. Your system parameters, k will go on increasing. Your root locus, it will start varying. It will take a trajectory. It will start giving different test points, and you're joining those test points. So for different, somewhere here the value becomes maximum when these two. So at this point they break. It has to break and it has to go. So now what will happen? This will break and go up like this, whereas this will break and come down like this. So it requires a breakaway point. What is break-in? Break-in will come if I have 2 zeros. Okay, if I have 2 zeros, what will happen? 2 things will come and join. Okay, there are 2 root locus which has to join these 2. It will be 2 root locus which will come and join. So here it will have a break-in point. Okay, 2 root locus will come like this and join. So this represents, the center point will be the break-in point. It goes away, it is breakaway. If it comes and joins, it is break-in point. Then the next, so we'll have to calculate this, we'll have to differentiate, because I said at breakaway point, k value will be maximum. So we'll find the value of k, differentiate it with respect to s. and we find the solution for this. Because it is a cubic equation, you will have three solutions. S1 1 minus 2 minus j 2.45 minus 2 plus j 2.45. And suppose we don't know how to calculate this. See, first let us you can find out the simple solution. Minus 2, when you substitute, it has to give 0. So now take minus 2, write 4 here. Okay, this 4 you write here, 24 you write see 4 you have to write here, then this 24 you have to write here, then 72 you have to write here, 80 you have to write here. Then the first solution, whatever you have got, minus 2. Okay, then minus 2 into 4. Initially nothing, just put this down here. Okay, so minus 2 into 4 is minus 8, 24 minus 8 is 16. Then minus 2 into 16 is 32, minus 32. So 72 minus 32 is 40. Minus 2 into 40 is minus 80, 0. So next it is going to be 4s squared. Okay, the next equation what you get is 4s squared, 16s and 40. Now find the solution of this quadratic equation. You get these two values. Okay, then uh, for these values, you will not know which is the actual breakaway point. You can have n number of breakaway point, but the actual breakaway point means what? Breakaway point should lie on the root locus, isn't it? The breakaway point, it should lie on the root locus, means it should satisfy the magnitude criteria. You substitute minus 2, you substitute these two values and see if it satisfies magnitude criteria. You get a positive value of k. You get a positive value of k. What means what? What does that mean? Positive value of k. See, if I have a suppose I have a I have my this is the imaginary axis and the real axis. This is j omega axis. Then what is positive? Here the k value will be negative. Okay, means what? The system is not stable. Here the k value will be negative. Whereas on this side, on the left hand side of the S plane, this is which is stable. Here the system is stable. Okay, whereas here the system is unstable. On the left hand side, k will be always a positive number, means it is a valid. If it is negative, means it cannot. On this side, k is it is it marginally stable. It is positive. Once it crosses, it becomes negative. Okay, that is very important here. Okay, so that is one way to identify it. Then you should also, if it is a point on the root locus, it should satisfy the angle criteria. Substituting it, I found out that it satisfies the angle criteria. How do you find out the angle criteria is, see what is the equation. Now what was the equation that we had? We had equation like okay, we'll just write here. The equation was k divided by s into s plus 4. Okay, then into s square plus, what is the equation? S square plus the equation was s square plus 4s plus 20, isn't it? Yeah. Now what you have to do is substitute here in the place, that is, it becomes k divided by, it is minus 2 plus j 2.45 plus 4 into this is minus 2 plus j 2.45 whole square plus 4 into minus 2 plus j 2.45 plus 20. Okay, when you do this, I got a number as at an angle. This is polar form. At an angle, I'll write it at an angle of 180 degree. So it is satisfying the angle criteria means if it satisfies an angle criteria, then it is a part of the root locus. So these all the three will satisfy the angle criteria. Hence, all the 3 points are the valid point on the root locus. You can substitute for the other two and also you can verify. Okay. The next is intersection where they meet the imaginary, the root locus where they meet the imaginary axis. Writing the routes array, we found out to be plus or minus j 3.16. Okay, correspondingly we had to find the angle of departure. Okay, we didn't have any now there are no zeros here, so we'll have to find the angle of departure from the poles. Okay, you had see with respect to angle of departure, where will you calculate? Angle of departure is always, you will have the y-axis imaginary and the real axis. If I have a pole, only for a pole here we calculate the angle of departure, and pole will have angle of departure, zeros will have angle of arrival, because root locus comes at an angle, it will arrive. From pole it will depart. So if I have a pole, will have angle of departure. It is angle of departure for a pole. So at where it will come, how it is going to, what is if this is the x-axis, the zero axis, what is this axis? This is the angle of, this will be the angle of departure. So this will also have an angle. So we had a pole here and we had one more pole at -4. Okay. So now what is the angle this pole makes with this? Okay, what is the angle this is making? This is around 118. What is the angle this pole makes with this? It is 90 degree. And what about this? This makes an angle of 62. This is making an angle of 62. You'll have to keep the protractor and check. This is making an angle of 90 degree. And similarly, this is making an of 118 degree. So then using the equation, you can just check that is, you will get an angle of departure as -90. This is angle of departure will be -90 for this pole and +90 for this pole. It will come out making the root locus, they have to come out from these poles. So if I have a pole here, how will the root locus, whether it is coming out like this, whether it is coming out this way, it is coming out. So how will I know how it is coming out? ಅದು ಯಾವ ಹೇಗೆ ಬರ್ತಾ ಇದೆ, that is what we are, ಹೇಗೆ ಬರ್ತಾ ಇದೆ, ಯಾವ angle ಮಾಡಿಕೊಂಡು ಬರ್ತಾ ಇದೆ, straight ಆಗಿ ಬರ್ತದ, 0 degree ಅಲ್ಲಿ ಬರ್ತದ. So all this we have to find out. So we will make an angle, we will assume it is making an angle of 90 degree. Okay. So then after this, this is again, as we said, we'll have to calculate the angle from the different poles, then find the angle of departure, and this will be the final root locus. Okay, now we will just draw. Okay, here I have the whiteboard with me. Okay, see how now this is a graph which I have got. I have just marked the see here, I have marked the points. This is the pole P1, then P2 at -4, then I have P3 and P4. And sorry, we don't have a 0 in this case. There is no 0. Okay, so I'll just remove the 0. Just draw the line. Okay, but at -2, what do we have? We have a centroid. Okay, at -2 we have a centroid. So now keeping the angle, that is, what is the angle? It has to be 45 degree, isn't it? We'll have to from the centroid, what was the two angles? What are the angles that we got? It was 45 degree. Okay, now keep here mark the asymptotes. You better mark the asymptotes. This angle, okay, see, this angle will be 45. This angle is 45. What about this angle from here to here? It is going to be 225, isn't it? This is going to be 225 degree, whereas this is going to be 45 degree. So you mark that, okay, along with, as you write, you mark this. Okay, then after that we'll mark the next one. Next we have to have 135, isn't it? We'll have to keep the other one is 135. Let us keep it at 135. Yeah, this is going to give us 135. Here again, let us mark dotted lines we have to put. After calculating the centroid, we have to do this. Okay, then we finished doing it. See, we have done this 45, 135, 225 and 315. Now, what is the next step? What was the next step that we did? The next step was that we calculated the breakaway point. Where did we have the one breakaway point was here, okay? We had one breakaway point here itself. This was one breakaway point that we had. We had one breakaway point here, okay, at -2. The other breakaway point was at -2, minus j 2.45. Okay, if this is -4, I mean +4, somewhere here we will have another breakaway point. Okay, I'll just mark it like this. One breakaway point, it is 2.5, less than 2.5. I have marked it as this is 2, less than 2.5 as 2.45. This is another third breakaway point. 1, 2, 3. So we have 3 breakaway points now. Okay, now next what? After this, where will it intersect the imaginary axis? 1, 2, 3. 3.1 is somewhere here. At this point, it has to intersect the imaginary axis. Let us draw it in some other color. Okay, somewhere here, it has to intersect the imaginary. If you have some other notation other than a plus into mark, because into is usually represented for a pole. So therefore, I've marked it with different color. And if you have understood, it is fine. Then the angle of departure. How do we calculate angle of departure? Again, as I said, from this pole to this pole. See, what is this angle now? This you have to mark, okay? We have to mark this. You have to mark this angle, and that angle you have to measure. That was around 118. Similarly, with respect to this, what is the angle? That is 90 degree. Okay, you can measure what was the angle, and again the angle with respect to this one. Okay, so this was around yeah, we got it at 64. Here we're getting it as 64. It is around 62. When I measured in the protractor, I got it as 62. So correspond this angle, that is from this angle was from the angle made by P2 with respect to P3, that was 60, that was 62. So now correspondingly you have to find out the angles and find the angle of departure. What did we find out? Angle of departure was -90. Means what? It comes out making an angle of 90 degree Okay, it comes out making an angle of 90 degree. It is coming out making an angle of 90 degree. This is also coming out making an angle of 90 degree. Now how do we draw the root locus? See, we have 4 poles. If you have 4 poles, that means we will have to have okay, first let me take, we'll have to have 4 root locus. Okay, let me consider one root locus is coming out from, one root locus is coming out from here. It comes here. Okay, then we have one more root locus which is coming out from here. Both of them, they're coming and they meet at this point. Next, what should happen? They should break away. Okay, one of them, it breaks and it goes up. It comes to this point. This blue line, blue root locus, it comes from here, it breaks and it comes down like this. It sees one more breakaway, it stops here. From this end, it has one more which is coming from the other end here. Okay, it is this, it sees a root locus which is coming from this end. Let me draw it in a little thicker, then you will understand. It sees one more which is coming out from this end. It is coming out at making an angle of 90 degree. Okay, then what happens? This comes out like this. It crosses the imaginary axis and it goes along this asymptote. What about this? It comes out like this, breaks, and it goes along with this asymptote like this. This is done. Now here we have 2 more. Okay, here what happens? What is happening here? This came out from here, broke, it went up. Again, it saw a breakaway point. From the other end, it sees that there is some one more line which is coming. It sees one more root locus which is coming from here. Both of them, they meet. This is also coming out at making an angle of minus 90. This is minus 9. It comes out, meets the imaginary axis, and it goes along with the asymptote. Whereas this one which came here, it breaks and it goes making along with this asymptote. So do we have 4? We have 1, 2, 3 and 4. Okay, so 4 poles, we have 4 root locus. This is how we have to draw, though this is not clear, but it is, these things have to be a freehand diagram. Okay, this was the 7th problem. Let us continue with the next one. This. Okay. The next is the 8th one. 8th one, sketch the root locus of a unit feedback system whose open loop transfer function is K s plus 1.5 divided by this value. So inspecting, we know there is 1 0. Where do we have the 0 from? Which is giving us a 0? The numerator will give a 0. Denominator will give poles. Okay, we have poles from the denominator. We have zeros. 0 and pole are nothing but S. Okay, what is S? They are energy elements. So it is nothing but energy elements. Poles and zeros means they are nothing but energy elements. Okay, now how they behave and all we'll see next when we draw the Bode plot. Next, we have 1 0 at s equal to minus 1.5. Then we have 3 poles at 0, minus 1 and minus 5. Okay, next come to the next one. We have to draw that 0, then all the poles you have to represent. Then the and that is root locus. Which is the region of root locus? Can we identify? Is this a region of root locus? Yes, because if I have a test point anywhere here, to the right of the test point, it is only 1, which is an odd number. Poles plus 0. Total pole plus total 0 is an odd number. So this region from 0 to minus 1 will be the region of, sorry, this is not minus 1, this is, say, yeah, this is minus, this value is going to be this has to be here, 0 has to be plotted over here. Okay, so the region is actually a region of root locus. Okay, we have a 0 here. This is, okay, so let this be the region of root locus. This is Z. So from here to here it is a region of root locus. From here to here it is region of root locus, whereas from minus 1 to minus 1.5 is not a region of root locus, because we get a even number. Okay, we get a even number of poles and zeros. Then from here onwards again it becomes a region of root locus. After minus 5 it is not a region of root locus. Then we have to calculate the asymptotes. We had see, we have one this is not there, this is a 0 is here in fact. So you have one pole. Okay, how exactly is it? See here, if I draw it, if I'm drawing it, okay, we had pole here, we had a pole at my, and we had a pole at here, and we had a 0, we had a 0 somewhere here. Okay, we had a 0 here. So now one of the pole, the root locus which starts from one of the pole will come and end here. Okay, or say the root locus which starts from this pole will come and end at the 0. But what about for these two? They'll have to come, one will come from this end, the other root locus will come from this end. They'll break, one will go up, the other one will have to come down like this. So you require two asymptotes. So you'll have to calculate based on the equation, it is 90 and 270. Then you have a centroid at minus 2.25. Then correspondingly, this is actually your 1.5. Okay. Then this is the 0 that we have. This we have the 0 here. The 0, I mean, we have the 0 at this point here. This is 1.5. Then centroid is at minus 2.25. This is not the 0. Okay, this is not the 0. We don't have it here. 0 is here. At 1.5 we have the centroid. Now keeping the protractor at the centroid, we have to mark minus 90, and this will be minus 90. Okay, this becomes minus 9, sorry, plus 9, sorry, is 90 and 270. Minus 90 is 270 is minus 90. So you have two asymptotes. Then yeah, you'll have to mark them. Then we have to find the breakaway point. As again, it is, we have 3, it is S cube, so you will have to have 3 breakaway points. We will have to check. Okay, here K value is positive, so this is a valid breakaway point. This is valid breakaway point, whereas the other 2 is not valid breakaway point. You can check using angle criteria also. If the angle, total angle, when you substitute here for this expression, see, when I'm substituting the value of S in this expression, when I'm substituting the value of S in this expression, if I don't get an angle, overall angle of 180 degree, then it means it is not satisfying the angle criteria. Okay, in the previous case, it satisfied the angle criteria, so it was a part of root locus. But here, if it doesn't satisfy the angle criteria, or if you get a k value is negative number, because your system becomes unstable. Here we are only talking about something which is stable, so you have to get a k value is positive. So this S1, I mean here this value is only, this is a valid breakaway point. Then find the imaginary where it meets. Again here you see k value is negative, so the root locus doesn't intersect with the imaginary and axis, and we don't have any root locus on the complex plane. Okay, it does, we don't have anything on this side. See, we don't have anything over here or on this, on the, I mean on the second quadrant or on the third quadrant. We don't have anything here or here, so there is no angle of, we need not calculate any angle of departure. Now directly looking at this root locus, see here, uh, 1z, this is, see, you have at 0, -1, and this is 1.5. This pole which starts, the root locus starts from this pole and ends at this 0. Okay, and you have one root locus starting from this pole, the other one is from here, other one starts from this point, it comes, it goes with a 90 degree, and it goes along with the asymptote, whereas this one comes out like this, breaks away, and then comes to follow the asymptote. So three poles, you have three root locus. Because you have a 0 here, this will come and end at the 0. The other two, they don't have, they come out from the breakaway point and start following the asymptote. See, they are not touching the imaginary axis. They don't have, they are not touching. And of the three, only 0.6, this is -0.6 is the valid breakaway point. The same thing you can do using the graph. Okay, here let us draw the okay. Now then, what were the root locus we had? We had one root pole here. Then suppose this is -1. We take 2 unit as one pole. This is -1 here. Then at -1.5 there was a 0. Let us consider this to be 0. This is 2, 3, 4, 5. Again we had a pole over here. And which was a centroid? Centroid was at 2.5. Somewhere here we had a centroid. Let us mark it with some other ink. We will mark it with the some other ink here. This was the centroid. Okay, then from the centroid, there were two asymptotes which were going at an angle of 90 degree. This is the two. This is one is, and one, the other one was 270 degree. Okay. So this angle, if I see, this angle will be 90 degree, and if you are marking, this angle will be 270 degree. 270 degree. Okay. So this is the asymptote angles. Then after this, we have to see the valid breakaway point was somewhere here. We had a valid breakaway point here, and there was no point on the imaginary axis. Now let us start drawing the root locus. What did we say? One of the root locus starts from this pole and it comes and ends at this 0. Okay, there is a 0 here, so ends here. Then we have two poles. So we'll have to have two more root locus. One starts and comes here. There is another one also which starts from here and it comes here, both of them. Then what will happen? This will break and it will come like this. Then it has to follow it has to go run parallel to the asymptote, so it will come down like this. Whereas what about the other one? Other one which comes out like this, again it will also go, it has to follow the asymptote, it will go like this towards the zero at the infinity. So this is how you have to draw the root locus. Now let us go to the next ninth problem. Sketch the root locus for unit feedback system whose open loop transfer function is given. From this we see zeros is not there. We have, this is order of the system is s cubed, so we'll have three poles at 0. Then it is minus 3 plus or minus j. Then mark them on the graph sheet. This is 1, 2, 3. Again, I said we'll consider two unit as one pole like that. Okay, then because there is no zeros, all of them have to follow the asymptote and go. So we'll have to have three asymptotes. The entire this becomes, if I consider a test point here, what will happen? If I'm considering a test point here, okay, suppose I consider a test point here, what will happen to the right hand side here? The poles and zeros count is odd. So this is a from here to here, from this end to this end, this is how much? Minus 3 to 0. So this is a part of root locus. Anything on this side? If I consider a test point here, somewhere here, we have 3 odd number. So the entire negative real axis becomes a part of root locus. Okay. Then coming to the asymptote, as I said, because there are no zero, all the poles will have to have asymptotes. And minus 2 will be the centroid, that is from point where the asymptotes will have to start. So using protractor we'll mark the asymptotes, then we'll have to find the breakaway point. Okay, we have two breakaway point, and these two breakaway points are the it is valid breakaway point. We have two breakaway point. Again, if it has to be a part of root locus, breakaway point will be a part of root locus. That is where they come and meet the poles, the root locus and break. So breakaway point has to be on the root locus and it has to satisfy the angle criteria. Again, if you substitute these values of s in the transfer function and you get the angle as 180 degree, it means it is satisfying the angle criteria. And although value of k is positive, so it is, both of them are the valid breakaway point. Then where do they meet the imaginary axis? At plus and minus j 3.2. Do we have yes, we have the poles on the second quadrant and third quadrant. So on the complex plane, so we will have to calculate the angle of departure. So now looking at this angle of departure, calculating, you get the angle of departure is minus 72 and plus 72. This is 72. Okay, this is plus 72. This value is plus 72 degree, plus 72 degree at minus 3 minus j. Okay, then yes, this is how the root locus is going to be. Okay, see here, we had a pole here, we have poles on the complex plane. These two poles, they come, the root locus come making an angle of 72 from both this. They come, they meet the real axis at this point and they break. One goes on this side, the other one comes here. When it comes here on from this end, it sees another root locus coming. Again they split one goes up, the other one comes down, and they intersect at the imaginary axis. Yes, we can try writing this. Let us see if we can do this using the screen whiteboard. Yes, let us clear this. Then using let us draw. Let this be a small line. Yes, then at 90°, we have to draw this at a 90°. Okay. Then what are, where were the poles? We had the poles at 0. At this point, we had a pole. Then at -3, this is 1, 2, 1, 2, 3. Here we had another pole, and also we had another pole here. Okay, there were no zeros. Then centroid, where did we have the centroid? Centroid was at minus. The centroid was at -2. -2 is, this is -1. Your centroid is going to be here. Okay. Let us mark it in some other color. This is the centroid. This is centroid. Then from here, again, keeping the angle 60°, you have to mark. Okay. We had 3, 60, 180, and that another one was at 300. Okay, now this represents 300 here. Okay, then anyway, 180° is this line itself. We will again mark. See, this is the centroid. I mean the asymptote. It starts from the centroid. So we know that this is 60, 180, and this is 300. So mark those angles. Then breakaway point, we had 2 breakaway point. Which was the 2 breakaway point we had? One was 1.18 was one breakaway point. This was one breakaway point here, and one more was -2.8, somewhere near 3. So this was another breakaway point that we had. Okay, one point was here, another point. Now, and imaginary, where will they cut the imaginary axis? At 3, that is 1, 2, 3. At this point, they'll cut the imaginary axis. Somewhere at this point, they'll have to cut the imaginary axis. Now let us start drawing the root locus. Okay, one root locus. I mean, what was the angle of departure? Yes, again, angle of departure was -72. Now, how do we write that angle of departure? See again. That is, we'll keep it here, and angle of departure will be something like this. Okay, and for this one, the angle of departure will be yes, like this. Okay, So we have the two angle of departure now. See the root locus, how will they come? They'll come out making, see that is, if this is the 0 axis, this is minus 72. This represents minus 72 degree, and if this is 0 axis, this represents plus 72 degree. Okay, both are angle of departure because the root locus is coming out from that. So now making an angle, one pole comes out like this, making an angle of 72. It comes and meets this. It sees one departure, angle of departure. There is one more pole, which root locus, which comes out from this pole. Okay, it sees here. Then one of them, they go along this asymptote to meet the 0. The other one, whichever was there, whichever came, it comes like this towards this point. Again, it will come here, it will see a breakaway point. It will come along this axis and it will see a breakaway point. From the other end, what is happening? There is one more root locus which is coming. Okay, one more which is starting from here. It is coming here. There is one more root locus which is starting from here. It also comes. Both of them meet. One goes like this along with, and it meets the imaginary axis at minus plus j 3.2. The other one, it comes and it goes like this, and it meets the imaginary axis and it will proceed. Okay, this will also proceed like this. So three poles, we have three root locus: red line, blue line, and the green line. This is how we will have to draw the root locus.